And welcome everyone. So today we will solve Leetcode problem 153, find minimum in sorted array using Golang. So this problem states that we were given an initial array and it was sorted in ascending order, but then it was rotated from the right side by n number of times. Like here n is 4 times, that means we pull the last element from the array, in this case 7, and then insert it at the beginning, that is 1 time, and then we do it 4 times. Our resultant array will look like this. So in this array we need to find the smallest element, and that too in O log n time. So one hint is that it suggests that we need to find this in this time complexity. That means binary search would be an option here. The other thing is, we know that the array was initially sorted, right? But we also know that at the pivot point the array will still remain sorted. Like here in this case the pivot point is 1, the pivot point is 1, so that means this array is also sorted, and this array is also sorted in ascending order. Here in this case the pivot point is this, so that means this array is also sorted and this array is also sorted ascending order. So now we need to figure out the minimum element. So we'll apply binary search. First we'll do is we will initialize beginning pointer to this and end pointer to the last, and then after that we find the middle element. Here in this case the middle element will be 5. So for now we will check whether our minimum element is greater than our last element or not. If our middle element is greater than our last element, that means there is a discrepancy in this array, right? Because ideally the middle element should be less than the last element in the sorted array, which is in ascending order. But since in this case the middle element is greater than the last element, then that means the discrepancy lies in this array, right? That means our minimum element lies in this array. That means our pivot point lies in this array. The pivot point basically I refer with as the minimum element in the array. The beginning pointer in the array. That is what the beginning pointer in the initial array. That is what the pivot point is. Now wherever the discrepancy lies, that means our minimum element lies there. So we'll traverse every array. We'll traverse every middle element, and we'll keep on updating our answer variable to the minimum of the middle element that we encounter, right? So in this case we encounter 5, so our s becomes 5. Now this becomes a sub array. Here we encounter 1, our s becomes 1, and now we see that middle element is not greater than last element. That means our sub array becomes this, and now here our middle element becomes again 5, but our response is 1, which our result variable is 1, which is still less than 5, so we do not update our result variable, and here we end our binary search. So let's code this up. I'll initialize big as 0. I'll initialize res as length of nums minus 1. I'll end, sorry, and I'll initialize res as 5000. Why 5000? Because that is our maximum element value that it can have. So now I'll do simple binary search. I initialize mid as big plus end minus big by 2. Now I will check if our response is greater than our nums mid. If it is greater than, then I'll reinitialize it to nums mid. Now I'll see if our nums mid is greater than nums end. It means our discrepancy lies in the second half. I'll initialize big to mid plus 1, else I'll initialize end to mid minus 1. Now at this point I'll just return this. I'll run this and see if it works. And we can see it does. I'll submit it now. And it works pretty efficient. Let me know if you have any doubts. Thank you so much.